Hi, hello friends. Welcome to our channel Study of Mathematics. In this video, we have to discuss some definitions about triangles. First, we discuss the median. Median means the definition is in a triangle, the line segment joining a vertex to the midpoint of the opposite side is called a median of the triangle. Median means in a triangle, the line segment joining a vertex to the midpoint of the opposite side is called a median of the triangle. This means this is the triangle ABC. Median is defined as in this triangle a line segment joining a vertex to the midpoint. One line segment is drawn from the vertex to the midpoint. We draw from the vertex A to the midpoint of opposite side. That means opposite side BC. Let the midpoint of BC, let it be D. Then this line segment, it is the line segment. And in the same way, let's take the vertex B and the midpoint of AC. This is the line segment. Similarly, let it be E and let it be. We can draw in a triangle the line segment. In this triangle, the line segment joining a vertex from the vertex to the midpoint of the opposite sides. Then we can draw a line segment from the vertex A to the opposite side BC to the midpoint. Let D be the midpoint of BC. Then this line segment AD is called the median of the side BC. AD is the median of side BC. Similarly, BE is the median of side AC. Similarly, CF is the median of the side AB. These are the median definition. Median means in a triangle, the line segments joining from the vertex to the midpoints of the opposite side is called the median. Then in a triangle, we have three vertices and three sides. Then we have three medians. These three medians are concurrents, means they are mixing at the point. These are concurrent lines. That means AD, BE, CF are concurrents. That means these are all are having the same point. That point is called the point of concurrency. That point of concurrency is called centroid. That point of concurrency is called centroid. Then that centroid point is denoted by Z. G is the centroid. G is the centroid. Centroid means the point of concurrency of the medians of a triangle. One more. Median means in a triangle, the line segment in any triangle ABC, the medians are drawn by using the vertex to the opposite side. Medians are drawn from any vertex to the opposite side. That opposite side having the midpoint from this line to midpoint of BC. This line segment is drawn from the point or any vertex of the triangle to the opposite side's midpoint. Then that is the one median and some more. That is AD is AD is the median of the BC side and BE is the median of the AC side. Similarly, CF is the median of the AB sine. In a triangle, we have three medians. These three medians are mixed with in or intersects in a single point. That intersection point is called the centroid. The intersection, these three lines are concurrent. Then that point of concurrency value is denoted by G. G means centroid of the triangle. Next, altitude. Altitude of a triangle. Altitude also in triangles. Altitude means in a triangle the perpendicular from a vertex to the opposite side is called an altitude of triangle. Altitude means, the definition is, in a triangle the perpendicular from a vertex to the opposite side is called an altitude of triangle. That means these are altitudes are drawn from this. This is the triangle ABC. In a triangle, the perpendicular from a vertex, we can take first from vertex A to the perpendicular. That means we can draw the perpendicular line from this vertex to the opposite side. Then that means AD is perpendicular to BC. A perpendicular line drawn from the vertex to the opposite side is called the altitude. Altitude of the triangle. In this also we have three altitudes. We have drawn the vertex A to the side BC. We have the altitude AD, and from vertex B to the side AC we have the altitude BE. Similarly, we have the vertex from C to the side AB, the altitude is CF. In this also we have three altitudes because we have three sides and three vertices. Then in this we have three altitudes. These three are intersect in a single point. That intersection point is called orthocenter. That means the altitudes of a triangle, in these altitudes are AD, BE, CF are altitudes of triangle ABC. In this AD, BE, CF are the altitudes of the triangle ABC. These three altitudes are concurrent. That means concurrent means these are intersects at a single point. Then that three lines are called concurrent lines. This point of concurrency, that means this intersection point is called orthocenter. Then the point of concurrency value is known as orthocenter. This orthocenter is denoted by the letter capital O. Orthocenter is denoted by the letter capital O. Altitude means in a triangle the perpendicular from a vertex to the opposite side. Then altitude is drawn by using the vertex to the opposite side. The perpendicular line can be drawn, that is AD perpendicular to BC and BE perpendicular to AC. Similarly, CF perpendicular to AB. These AD, BE, CF are altitudes of a triangle ABC. These altitudes are concurrent to each other. Then point of concurrency is called orthocenter, and orthocenter is denoted by the letter capital O. Next, the internal bisector angles or angular bisectors of a triangle. Next, next discussion is the internal bisector angles or angular bisectors of a triangle. Definition is a line or line segment that divides an interior angle of a triangle into two equal angles is called an internal bisectors or angular bisectors of a triangle. This can be explained in this. This is triangle ABC. In this is the angle A and angle B, angle C. A line segment or line that divides an interior angles of a triangle. That means in a triangle, the internal angles are angle A, angle B, angle C. Already we know the internal angles of a triangle, the sum is angle A plus angle B plus angle C is equal to 180 degrees. This is the known statement, and internal bisectors or angular bisectors are drawn from the two equal angles. Any line that divides this angle or this angle, either this angle, into two equal parts. That means if angle A is theta, then this line divides this angle into two equal parts. Two equal parts. Then this angle is equal to this angle. Then a line or line segment, this line AD, let it be D. This line AD is divides the angle A into two equal parts. Then that line AD is called internal bisector angle or angular bisectors of a triangle. That means a line or line segment AD is divides the internal angle into two equal parts. Then that line is called angular bisector. Similarly, BE. B is the angular bisector because this divides this angle into two equal parts. Same. CF. CF is another internal bisector line. These three internal bisectors are also concurrent to each other. Then that point of concurrency is called incenter. Point of concurrency is called incenter. Incenter of a triangle ABC. That incenter is denoted by the letter capital I. The incenter is denoted by the letter capital I. The incenter is found by drawing all internal bisector angles, that AD, BE, CF, or the internal bisector angle lines of the triangle ABC. These three lines point of concurrency value is denoted by capital I. Capital I means incenter of the triangle. By finding the incenter, we have formula. That formula is if capital A of x1, y1, B of x2, y2, C of x3, y3 are the vertices of a triangle ABC, let AB, the distance between the distance of side AB is, let it be C. The distance of side BC is small a. The distance of side CA equal to B. Then the incenter formula I equal to AX1 plus BX2 plus CX3 by A plus B plus C, comma AY1 plus BY2 plus CY3 by A plus B plus C. This is the formula for finding the incenter of any triangle. For finding this incenter, we have only the vertices of a triangle and the distances of the values. By using these, we have to find out the incenter of a triangle. Next, the next topic is perpendicular bisector. The perpendicular bisectors of a triangle. The definition is the perpendiculars of a triangle or lines passing through the midpoint of each side which are perpendicular to the given side. Which are perpendicular to the given lines. That is, this is the triangle ABC. This is the triangle ABC. The perpendicular bisectors are drawn from the vertex to the opposite side, but this line can be perpendicular to the opposite side and also passes through the midpoint of the opposite side. First we can use this is the midpoint D, then this AD. Here the perpendicular bisector line can drawn from the vertex to the opposite side and opposite side. That means that line can be perpendicular to the opposite side and also that this perpendicular bisector line is perpendicular to the opposite side. That means the line AD is perpendicular to BC and also D is the midpoint of BC. The perpendiculars of a triangle are lines passing through the midpoint of each sides which are perpendicular to the given side. That is, this perpendicular bisector is the perpendicular to the side and also this line is touch the side BC at the midpoint of side. Similarly, this is the E perpendicular and CF. That means here AD, BE, CF are the perpendicular bisectors. Perpendicular bisectors. AD is drawn from the vertex A and BE is drawn from the vertex B and CF is drawn from the vertex C, and these are perpendicular to the opposite side. That means AD is perpendicular to BC, BE is perpendicular to AC, similarly CF perpendicular to AB, and also D is midpoint of BC, similarly E is midpoint of AC, F is midpoint of AB. Here AD, BE, CF. AD, BE, CF are the perpendicular bisectors. These bisectors are perpendicular to the opposite sides and passes through the midpoint of the opposite sides. Then these three perpendicular bisectors are also point of intersects at the same point. Then these three AD, BE, CF are concurrent to each other. Then that point of concurrency is called circumcenter. Point of concurrency is called circumcenter. Then that circumcenter is denoted by the letter capital S. The circumcenter denoted by the letter capital S. For this, we have some important point is that is in a triangle ABC, if A of x1, y1, B of x2, y2, C of x3, y3 are the vertices and capital S of x, y is a circumcenter, then we have SA equal to SB equal to SC. That means from this circumcenter to the any vertex, this distance is equal. From the circumcenter S to the A, this distance is equal to circumcenter to the vertex B, the distance equal to the circumcenter to the vertex C is equal. That means SA equal to SB equal to SC. By using this condition, in above problems, in next exercise problems are solved by this condition. SA equal to SB equal to SC. These are some definition and important points for the next exercise problems. In next exercise 3E, we have most important 7 marks, 2 marks and 4 marks problems. These are very important for the IPE exams. Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.